Kathleen, so take it away, Kathleen.
Hi. Well, first of all, it's absolutely incredible for me to be here because my experience in open source is to have a project which I was absolutely felt compelled to create. And then some people in the community, Llewellyn Falco being one of them, kind of held my hand and dumped it online. And I'm going to say dump because I was really like, Llewellyn, what am I supposed to do? And if you know Llewellyn, he's like, well, here's the high dive. There you go. Push! And literally it got named the morning that he said, you need a name right now. And so it's been quite an interesting project to get this far. But because of that, I'm in a little different position than some of the people that are talking here, because I actually am not yet certain whether this project should go forward. And I'm actually showing it to you both to tell you a little bit about what I've done, show you what it is, and then also I hope that after this she'll give me some feedback as to anything that you think about this, because it's a pretty big thing, and I created it for 2 projects of my own, and whether it should have a life beyond that, I think, is still an open question. So let's get started. Sometimes I feel like this, especially in the open source world. And this is a quick agenda. I know that's really old style to do an agenda, but because I didn't have an abstract, I thought maybe I should tell you something about what we're going to do. So Rosalind DOM is a project I created which attempts to create code the way you think. That's the goal behind it. So this is where we're going. And before we start, I'd like to have us all kind of be able to think about the same code. So when I talk, and I didn't create a slide for this, so I want to just do this out loud. So what I want you to do is just go ahead and help me out, because we're going to come back to this thought. Think of a customer class. And this customer class is going to have a first name and a last name. And let's give it a birth date, I think. And why don't we inherit that from like a biz class base to give some common functionality there. And let's see what else we should do with it. Oh, let's give it a constructor. Let's have it have a constructor that takes the parameters for the properties that we're going to have in the class. So you guys got some in your brain right now? Okay, let's talk about what's in your brain. How many of you have a specific language in your brain and what you think's in your brain right now? Raise your hand if you have a specific computer language. It's going to be an awful lot of you. Raise your hand if you have any syntax, any semicolon, any required space, anything like that in your head. Okay, so that's maybe half to 2/3 of the people before. Raise your hand if you have all the syntax. Every semicolon, every new line. There'll be a couple people. It's a little more than I expected. Okay, raise your hand if you had a problem that I didn't go from the top to the bottom of the file. I'll annoy somebody with that, okay? I gave you the constructor after I gave you the properties. Raise your hand if it annoys you that I didn't tell you what the data types were. Anybody? 1. Okay. So as you can see, there's an awful lot of commonality in the way you guys thought about it. And there's one thing I forgot to tell you about it. It implements iNotify property changed. And if you don't know what that means, don't sweat it. But if you do, add iNotify property change to it, okay? Did anyone add all those lines of code that iNotify property change required? A couple people, 1 person at least. Did the rest of you go, and that ick, and that stuff? Just, yeah, is that what you did? Okay, so my proposition, my base core proposition is that, oh, I forgot to ask you something else. I asked you if you had a computer language. I didn't ask what they were. Raise your hand if it's C#. Okay, raise your hand if it was VB, JavaScript, Java, anything other than C#. Oh, well, we have a C# crowd then. Raise your hand if you think it would have been a problem if you were sitting here and your language of choice was Java. Do you think it would have been a problem at all? JavaScript, do you think it would have been a problem? Why would it have been a problem in JavaScript? I said it inherited from something, and the concept of a class is different. Anybody here know a little bit of Haskell? Anybody? A couple people? Could we have done that in Haskell? I lost you about 2 sentences in when I said property. Haskell has no properties, okay? So we have paradigms, and within those paradigms, we think largely the same. This is why we can talk to each other. Human beings, abstractions to us are tightly integrated with the way that we think and talk. This is why verbal communication is different than singing and is different than other types of communication. So this is the way we work as humans. So I set out initially to do 2 projects in the generative space. We'll talk briefly about them, but they're not the important part of this talk. And when I first began these projects, they were incredibly complicated because I was building them on top of Roslyn directly against the syntax and semantic tree. And while I was building them against that, I had all this Roslyn stuff woven into these relatively hard problems that I was solving. And it didn't work real well, and I threw it all away about a year ago and started completely over my first building an abstraction with Roslyn. So I have an abstraction over Roslyn, and that's what Roslyn DOM is. That's the project that I'll talk to you some about today. So is Josh and Amadeus here? Oh, there you guys are. And Omar's here. Do we have anybody from the team here? They're probably upstairs. That's fine. Okay. So right now, there's at least 4 teams in the world that have done something complicated with Roslyn, something challenging. And I'd put myself as the least of those complicated ones. And one is the team who built the compiler, and one is the guys here up front who did Code Connect, and the other is these guys over here who did Ozcode. So these are people that went in and used Roslyn to do something complicated. And all of these 3 teams all said, I need to do something to get my fingers into Roslyn. And there's different ways that you can make Roslyn a little bit easier. But when you think about that, let me see if the next place I'm going is to talk about Roslyn. Yeah, this is a compiler. I'm going to give you like the 10-second version of the compiler course. So we start with source code. We have a parser. It creates a syntax tree. A symbol loader creates symbols. And we wind up with a semantic tree, which you can output as IL. So that's Roslyn in a nutshell. So if we look at this and we look at what the difference between a syntax and a semantic tree is, when we look at this line of code and that word console, it has a meaning in your head. If I say the word console, you have a set of functionality that you think when I say that word. So that is just a set of characters that is an identifier. It's not just any random characters, but it's a set of characters that makes an identifier within a syntax tree. We then resolve that, and in the semantic tree, it is a specific pointer to a location. That's what the semantic tree does with that. Now, I say system.console because that's probably what you meant. But it might not have been. It might point someplace else because of the environment. It could go to a different namespace. So the different namespace means that this resolution is very contextual. You with me so far? So what Roslyn does here is, well, before we go there, then when we look at things like ReSharper and the first version of Ozcode, and I think you guys waited for Roslyn, right? So they were lucky. They were in university before. I should not say that. Maybe I shouldn't say that. So they got to start with Roslyn. But Ozcode and ReSharper had to build their own parsers, build their own stuff, rip it apart themselves. It's a lot of nasty, nasty work. They all had to do that. There was a little bit of language services, but they were very wimpy. So along came Roslyn. Roslyn exposes the syntax tree. It exposes the symbols and the semantic tree. I'm sorry, that wrapped for a minute. Now it's unwrapped. And it also created language services, which everyone gets to use and draws on the syntax tree, the semantic tree, and the symbols. Now, everybody can be happy and use the language services. And I play way too much with PowerPoint. So I really like that demo. I really like that. Okay, good. Okay. So I'm going to very quickly blast through this next part because this is not a Roslyn talk, but it may help you if you're not. If Roslyn is still that thing they're building for the compiler, and that's where you're at with it right now, I want you to just real quick see this next part. So Roslyn has a compiler pipeline, which is what we just looked at. It's all lighting up. That's the compiler pipeline. On top of that, there's a set of APIs. The APIs has a pretty close relationship with the underlying pipeline because that's what its job is. And sitting on top of that is a set of services, and the colors here are the primary thing these services are related to. So here we've got language services, which include many different things, at least one of which I hope will get you a little excited. We can get to navigate to, we can get to find all references, we can get to rename, quick info, signature help. All these things are available to us. This is a fairly old slide, so I haven't updated to look at the current set of services. But that's a fairly, that's a list of the services that you can get a hold of and work with while you're working with Roslyn. So it's a pretty powerful system we've got. It's really amazing to have this much formality around it is new. Other people have exposed some syntax and semantics before. Now, the best thing about Roslyn is what I just showed you. It exposes the syntax and semantic models and trees of the compiler. That is an amazing thing for us. Would anyone like to guess what the worst thing about Roslyn is? It exposes the syntax and semantic trees of the compiler. And if you've worked with it, you know this is a fairly detailed thing because they didn't write it for us. They wrote it to be a very good compiler. That's exactly what they needed to do. So one of the ways that this plays out is in what an attribute means. So if we look at an attribute, there's two ways to express it. I think there's nobody in this room that wouldn't see that and say, yeah, that means the same thing exactly. My brain is going to read either of those. If you see them together, your brain will differentiate them. But if you saw either of those independently and you then talked about it, you would say the same thing no matter which one you'd looked at. I'm real sure of that. Maybe not every single person in the room, but most of you. So this is what happens inside of Roslyn because it has to round trip that. They are different. Those look different inside the syntax tree. The semantic tree collapses that and they no longer look different. So Roslyn DOM sits on top of this, and there's your class. That's the one that you talked about before. And if I had just given you a piece of paper, you would have written something. Most of you would have written something very similar to this. A couple of you might have written this, but it's rare. Most people are not going to write this. They're going to write the summary if you ask them to describe it. That's what UML is. So that's the way we think about this. It's a very natural way to think about it. That's code and that's metadata. So this is kind of just the history. It's like I thought, well, what if you had that? Because if you notice at the bottom of my agenda slide, my real passion here is to empower other people with Roslyn DOM. That's whether or not it's going to have a life of its own. I can use it for myself. I know how to do that. So if you had it, what would you do? If you could do it easily, if it wasn't hard to do things against this idea in your brain, what would you do? What visualization would you come up? What complex refactorings would you come up with? Simple refactorings do not need this. The ones that I'm teaching, part of Paul's site and other places, they generally don't need this. So I was sad when it wasn't going to be what I wanted, so I built it. That's my story. It is on GitHub and NuGet with my name. And these are sort of the goals of it, and I don't want to go too deep into this except to briefly mention mutability. When I added I notify property changed, none of you threw away your old idea and made a new one. That's not the way we work. You added it on top. That's the way we work. So while Roslyn truly needs to be immutable, if you're working with this, it does make it more difficult for you. So I keep pointing there instead of there. So I call this a common language agnostic mutable DOM. Because the one I built is perfectly agnostic between VB and C#. There's no real difference there from this point of view. There are differences in how it gets expressed. There are differences between the languages in terms of scoping and some other things that are very important. We can ignore that. Okay, I can also build a different DOM, a different model for VB6, for JavaScript, even for Haskell. And if I have two models, I can map between them sometimes depending on how much work I want to put into that problem. I can take on-error goto in most VB6 code and turn it into a try-catch. That's a pretty big change, and I cannot do it. I cannot do it by parsing code and dealing with strings. I have to do it by understanding code. So the basic model is that we take source code, we put it in the model, we do whatever we want to the model, we turn it upside down, inside out, play with it as long as we want, and then we output it. And we can output it over the same file, so we can, of course, just change the code, but it's by creating it, outputting it, and sticking it back out, because Roslyn will always be immutable, the underlying Roslyn. So, what I do with this is technically is that I use the trees of Roslyn, and I would not have done this project had I had to do any of this work. So all of the work to go from the string into the first meaning, into real meaning, I just go into a simpler meaning. Happens with somebody else's work. So this is another example of where Roslyn is different than the way you think. I think it probably takes you just a second to see that the difference in that code is the way the namespaces are declared, and you would probably see both of those in the same exact way. So this is another case where actually, I was going to have you guys do a multiple choice test. Can I have you guys do a multiple choice test after I already told you the answer? You can tell me if it's different. Do you think of these as two nested namespaces, which is on the left? Do you think of them as what's on the right? Do you think of them differently? Would you actually perceive them differently? Or... So is it, raise your hand if it's A. Raise your hand if it's B. A couple people on A. Raise your hand if it's C. A couple people on C. So people sometimes are more, they're just, it's okay. There's no good and right answer here. It's just I want to help you understand that these people around you are answering these questions like you do. What about this code? It's the await keyword. That's the point here. So it's a single set of code top to bottom. Something special happens. It's a block of code before and a block of code afterwards. It's basically a continuation. It depends on what I'm doing, or I've got no clue, I'm not a .NET programmer, which in this crowd, I just found out is probably not going to happen. So who goes for A? Okay. Who goes for B? Okay. Who goes for C? Yeah. Okay. So Anders had a good idea that we wanted to do A. Lots of people did that. A lot of people have had to unravel that, and they think about as B. And then I actually guessed that if I actually watched you work, there would be times you actually would do more of C than you think right now. Because certain times, it's very helpful. I was going to go completely with B initially on this design, and I decided I have to figure out a way to do both, and that's why it's not done. So when I talk about the fact you have common ways to think about code, this is what I mean. These are details that Roslyn has to resolve in a way that works for a compiler, and you get to resolve in a way that works for you if you're using a different tool. This is just a real quick dependency graph, and the only real thing I want you to see here is that there's 5 working projects as part of Roslyn DOM. This has a definition. It has a class called class. It has a class called property. It has a class called function. It has a class called namespace. So this is the actual model, the actual document object model right there. The C# factories load that, and it's only the C# factories that care about the C# code analysis. There happens to be a break right now, and I have just gone through a big bunch of issues around getting up to their latest RC, and so right now I've got some incorrectness in my references because NuGet made me insane. But that will get fixed, so that we can just go to the VB factories instead. I'm going to really quickly blast through why I did this. It's going to be about 2.5 minutes on what my projects that I built on top of this, because I want to get back to the dream and where I want to go. I can't do that unless I give you this much on code generation. This is my view of generating code. I'll talk to you a little bit more about why I still think code generation is relevant when I do the dreaming part, but we have a template, we have metadata, we throw it together, we get magic. Okay? So if we're doing that, then both the metadata and the language are fairly significant, and I will blast through parts of this. So there is a way to have a small description of code and then infer the rest of the information. This is a code first class. It has notified property change, so it implies that it's in a desktop. Excuse me. But that you could use pretty much for code first. You can yank off the base class if you want. Code first is the Indy framework, code first right here. That is a different problem. We can also create metadata about this. This is a semantic log based on event source, which is part of .NET 4.5, and I can do 8 hours on that if anyone ever wanted to listen to a workshop on logging, which is unlikely. So these are simpler versions. These are simpler versions. I will now blast through the next parts of these slides because we don't have time. And that's basically what we want to accomplish. I am also going to blast through an alternate template language. If you know what T4 is, the next slides I will blast through because I'm running late are going to be a replacement for T4. So as they go by and you actually can't see them, you will at least know what I intended to do. That's T4, more T4, broken T4, new language, new language, new language with the breaks underlined in squiggly. Okay, we're done. That's it. That's all we're going to say about templates right now. Because I really want to show you this. I want to show you my dream that I am slowly working towards, and Well, I have so much respect for people like the OzCode and the Code Connect teams that can work with the Visual Studio Canvas, because they've both also worked with the Visual Studio Canvas. This is what I want to build. On the left is the smallest description of the code. It's the code in your brain, it's the metadata, it's the small, short, simple version. On the right is the real code. And when I talk about this, I often get asked, well, why do you even need the real code then? And to me, there's two answers that will not go away for a very, very long time. One of which is you need to debug the real code. You need to see it while you're debugging. Because unlike Entity Framework, you wrote these templates and you screwed the templates up, and you need to understand what the real code looks like. And the second thing is there's many jobs you're doing where you actually want to understand what's going on, the real stuff. And you want to be able to search it and do other things with it. So I believe that the real code remains important. And so this is a mock PowerPoint-only UI right now. And then from this, you can expand what's on the left. You'll be surprised at how much more difficult it becomes to read. Oops, happy humans. Okay, there. It's exactly the same code on the left. I just spread it out. I spread it out so it aligned with what's on the right. And then once I do this, these are two modes. That's what this arrow is intended to be. This is to talk about how they synchronize. When you click on any one of those arrows, it shows a fractional part of a template that goes between those two pieces. So this is one. A property gets taken across like this. Don't worry about the template language since you've never seen it before. But there is a template. Now the research that I'm still in the middle of doing is that given these three pieces, and I will tell you that there are very smart people that do not think this is going to happen, but nobody knows yet. In the interesting set of code, not the pathological code, given any two of these three, can you create the third? And that actually becomes a very, very interesting thing if the answer is yes, we can. Because then you can comfortably round trip this code based on the template. And that means that you can edit all three pieces anytime you feel like it. And that becomes an extremely powerful way to think about code. It's my guess that if we did this, you would be in this code right here about 80% of the time. You'd be in this code about 15% of the time, and you'd be in this code about 5% of the time. That's what I think you would do. Which means that all that crap code you have to look at every day, you've got 100,000 lines of code in your application, and you take all that 100,000, and 80% of the time it acts like a 10,000 line application. And then the rest of the time you have to deal with it only in small pieces to know more detail. That's my dream. But really the point, yeah, I've got lots of details. I can talk about this for a really long, scary time. But my real dream is that we have, what? How many millions of developers do we have? How many of those people are like you that have extra thoughts about maybe what the world could look like that I never thought of? I can tell you that I never dreamed anybody would do the things that either OzCode or Code Connect are doing today. I did not see any of that. They've got some absolutely amazing different ways to think about it. I never would have come up with ReSharper, except that it's been around so long we think of it as just part of our reality. We don't even think of it not being there. So what I'm really, the reason that Rosalind DOM is a separate open source project is because maybe, if the world has something that they can walk up to and say, well, all this work with this really complex syntax and semantic tree, I can push that behind an abstraction. And I can do very, very simple code against what I actually need to accomplish. And so that's what I would love to talk to you later about. I will come back to the agenda and say, hopefully I pretty much did that in 30 minutes, not real deeply. And I still feel like that sometimes, especially with open source. I love the fact that everybody's been so sweet to me throughout my blundering experience. I would suggest if you don't have a compelling desire to build something, you contribute, especially first, until you have something you feel compelled to create. It's a much smoother route. And finally, here's my contact information. So if you want to follow up with me, catch me later today or catch me on any of these mechanisms, and I'd be thrilled to talk to you more about all the ideas that I just set out there right now. I don't know that I actually have 1 minute for questions. That's what my clock says, Troy. No. I did all of this that fast, and I've got 5 minutes. You told me 11:50.
You got 4 minutes. All right.
Dude!
Anybody got
oh, man. Okay, I got a question back there. Let's talk.
All right, Ian.
Let's talk. We got a mic coming because we've got a recording going, I think. And so let's go ahead. I'm probably bouncing around the screen, making the videographer crazy. Yeah.
One of the questions with these things normally is, what's the debugging story like?
Okay, let me go back to my dream. Okay, let's just go back to just that. I actually deeply agree with you, and that's why the blue part exists. It is the code that is compiled, is the code you debug against. I know there are people that are working very hard on the question of debugging in something like this, in the stuff on the left. I believe that that is unimportant, and you won't do it. That when you're actually debugging, you actually want edit and continue on the right. You actually want to make changes. And now it's all out of synchronization, and you resynchronize. Because I believe that finding what you need to fix over here is a quite independent problem from deciding whether the problem came from here or there. And once you do that, it's a quite independent problem to change your template. And in many cases, it will be a different person who does it. So that's my view of how we attack this after a couple decades in this field. That's what I think we need to go to on the generation side. Okay.
One more question. Anybody? All right. Over here.
If you take some examples of things like async await and like yield return,
right?
These are things that we kind of get to express what we're thinking, and a transformation occurs.
Absolutely.
Right? So I guess what I'm curious about is, in those cases, I pretty much never feel like I need to actually debug and step through the code that the C# compiler generated.
Right. Right.
So
why do you have to do this? Is that the question?
You know what? I
will tell you, if I understand your question, I will tell you the answer that I have, which is that I trust Anders Heilsberg's team way more than I trust me. I trust the NE Framework team and an open source project of that magnitude way more than I trust me. That these templates are very personal. This is this project's template. It'll start out being something standard, but if we can't make that unique to your project, we can't have the power that I believe we need to even make the system worth building. And because this is a much more mushy, we can make mistakes anywhere system, then I believe that you do need that, and that's why I believe that you need that approach. It's a fantastic question.
All right. Well, that is the time we have for this talk.
Thank you.